Hello guys and welcome to a new video in physics. In this video we will complete lesson 4. We reach to equation of motion. A straight line on a position time graph can be represented with the equation x equal to vt plus x initial, which is x final, the final position, equal to v, which is the velocity, multiplied by the time plus x initial, which is the first position. Here we have a problem. A car is initially 6 meters east of the origin. It drives west at a speed of 12 meters per second. What is its position after 1.2 seconds? So as we learned in the beginning, we should write the noun and the unknown from the question. Here we have a car initially 6 meters per second. That means the first position for the car, which is x initial, equal to 6 meters east. It drives west at a speed of 12 meters per second. So we have the velocity, which is equal to 12 meters per second to east. What is its position? So I need the final position, so x final, the unknown in this question. After 1.2 seconds, 1.2, that means we have the time, which is t equal to 1.2 seconds. In the beginning, we will write our equation, which is x equal to vt plus x initial. Now we will write the numbers. We need to calculate x final equal to v, the velocity. Here we have the velocity 12 meters per second to west. Because here the direction is to the west, so we should write it as minus 12. So we have minus 12 multiplied by t, the time, which is 1.2, plus 6 meters, which is x initial. In mathematics, in the beginning, we should do the multiplication and after that the addition. So the result of the multiplication here, minus 12 multiplied by 1.2, the result plus 6 meter, it should be minus 8.4 meter. Or we can write it as this, x equal to 8.4 meter, and the direction is to the west. Here we have also an example problem number 4 on page 50. So the figure shows a motorcyclist traveling east along a straight road. After passing point B, the cyclist continues to travel at an average velocity of 12 meters per second east and arrives at point C 3 seconds later. What is the position of point C? The figure here, we have a motorcyclist in a position B, which is equal to 46 meters east. So we have the first position, or x initial, equal to 46 meters east. We need to find the position in the point C, and we have the velocity and the time. So in the beginning, we should write the noun and the unknown in this question. We have, as we said, the velocity, which is equal to 12 meters per second east. So v equal to 12. And also we have x initial, which is equal to 46 meters east. X initial, we should write it with the noun in the question. 46 meters east. And also we have the time here, which is t equal to 3 seconds. We need to find x final. In the beginning, we will write our equation, which is x final equal to vt plus x initial. V, we have it in the question, which is 12 multiplied by the time, which is 3, plus x initial, which is 46 meter. In the beginning, we will do the multiplication, and the result we should the result of the multiplication plus the 46, that should be equal to 82 meter. So here we have the result. Because of the result is positive, so the movement, it should be to the east. Now we have practice problems in the same page. So we have the first question, which is 32. The diagram at the right shows the path of a ship that sails at a constant velocity of 42 kilometers per hour east. What is the ship's position when it reaches point C relative to the starting point A? If it sails from point B to point C in exactly 1.5 hours. Here we have figure 24. We have a ship sails from B to C. So we have the x initial, and we have the velocity and the time. We need to find the position in the point C. So as we learned in the beginning, we should write the noun and the unknown for this question. We have the noun here. This is for question number 32. We have the noun and the unknown. The noun here, we have it. We have x initial in the figure. X initial equal to 25 kilometer. Also, we have the velocity v. Sorry, just v. V equal to here we have it, 42 kilometers per hour. What is the ship's position when it reached to the point C? And also we have here the time t equal to 1.5 hours. We need to find x final. So we will write our equation, which is x final equal to vt plus x initial. X final equal to the velocity, we have it, which is 42 multiplied by the time, which is 1.5, plus x initial, which is 25. So the final result for x final, that it should be equal to 88 kilometers. And this is for the first part in the first question. Now we have question number 32. Sorry, 33. For question 33, another ship starts at the same time from point B, but its average velocity is 58 kilometers per hour east. What is its position relative to A after 1.5 hours? So for the same figure, and he told me that the movement from the same point. So we have, in the beginning, we will write the noun and the unknown. The noun here, we have x initial equal to 25 kilometers. Also, we have the velocity, which is equal to 58 kilometers per hour. After 1.5 hours, so we have t equal to 1.5 hours. The unknown in the question, we need sorry, what is its position relative to A. So we need to find X final. Our equation is X final equal to VT plus X initial. X final equal to V, we have it, which is 58 multiplied by the time, which is 1.5, plus X initial, which is 25. So the final result for X final, it should be 112 kilometers. And this is for question number 33. Now for the other question, which is 34, we have, what would a ship's position be if that ship started at point B and traveled at an average velocity of 35 kilometers hours west to point D in a time period of 1.2 hours. In this question, we also have the movement from the same point, which is 25 kilometers, and also we have the velocity and the time, but here we have the movement to the west. So we will write the noun for question number 34. We will write noun here and unknown. The noun here we have it, X initial equal to 25. This is kilometers. And also we have in the question a velocity of 35 kilometers per hour west. So we have velocity equal to 35 kilometers per hour west. In the time t equal to 1.2 hours, we need to find X final also. In the beginning, we will write our equation, which is X final equal to Vt plus X initial. Now we will write the numbers X final equal to. The velocity here we have 35 kilometer per hour to the west. So because of the direction to the west, we should write it as minus 35 kilometers per hour multiplied by the time, which is 1.2, and plus X initial, which is 25. The final result, X final, should equal to 17 kilometers. This is for question number 34. The last question, 35, is the challenge. This is for you. So please solve it and send it to me. Until here, we reach to the end of our lecture and the end of lesson 4. See you soon in another one, inshallah.